Today I'm going to talk about some techniques for tuning conjunctive queries. That is, queries where multiple filter predicates are combined with the AND operator. So for row to be returned, all the predicates must be true. This follows our previous discussion of tuning disjunctive queries, which use all. An issue with conjunctive filters is that B-tree indexes are often of little or no use. For example, consider a simple query in the Scott schema. First, I'll enable the auto trace facility so that we can see what's going on. And now my query. Select a name from AMP where depth equals 10 and job equals Clark. And back comes Mr. Miller. That was executed with a full table scan. And at the moment, there really is no other way to do it. So, perhaps I can try to optimize it by creating some indexes. First, an index on job. Create index JI on AMP job. Then a second index. Create index DI on AMP depth. And run the query again. It's using one of the indexes. The DI index has returned the row IDs of the 3 people in that department. We've then gone to the AMP table and retrieved the 3 rows, checked the other filter, job equals Clark, and we've thrown away 2 of the rows to be left with just 1. That's pretty inefficient. It was 3 times as many table accesses as were needed. So the index was useful maybe, but by no means perfect. I could hint the use of the other index, like this. Select, hint, index AMP.ji. What do I get now? Well, it's used the JI index, but the results are even worse. We have now retrieved 4 rows and thrown away 3/4 of them. So you might think, can I perhaps hint using both indexes? Well, you can try. Index AMP.ji, index AMP.di. We can hint both if we want to. Doesn't work. We're using one index only. And the hint report down here is explaining what happened. The hints parsed correctly, but one of them was not used. And that's your basic problem, that single column indexes, Oracle has to choose one. It can't use them both. Of course, a composite index might help. But if you start creating composite indexes, a composite index across both columns, you're perhaps creating an index for just one query. And that can be the beginning of a slippery path towards a ludicrous multiplicity of indexes. Bitmap indexes rather than B-tree might also be a possibility if you have the Enterprise Edition licenses and if you can accept the possibility of excessive row locking that tends to happen with bitmap indexes. So all too often, conjunctive queries end up with a pretty poor execution plan due to restricted use of indexes. So what can we do about this issue? Well, there are some hints that can help, if indeed you are permitted to use hints in production code. First, and equal. So there's my hint, and equal AMP.di.ji. So I've given the table name and both the indexes. And look at that. Back comes Mr. Miller. And the and equal operation has decomposed the query into two subqueries, both of which were indexable. And that's getting my row IDs for department, people in the department. That's getting the row IDs for the people with the appropriate job. Merge them and return the one row that matches both predicates. The and equal operation, by the way, has a bit of a bad reputation, and the optimizer will rarely choose it, but there are occasions when it is good. Note instantly the cost has actually gone up. The previous cost there was 2, it's now gone up to 3. I don't want to get concerned about that. We're dealing with such tiny data sets here that the cost figure is basically meaningless. It's the rewrite that made both indexes usable that matters. There's another possibility. The index combine hint. So select index combine, table name, and the two indexes. And that is a very nice transformation. We mentioned just a moment ago that bitmap indexes might be a nice solution to this sort of problem. And that's pretty similar to what we've got here. Oracle has built the bitmaps dynamically from the B-tree indexes and merged them to identify the one row that fits both the filters. And there's no risk here of the row locking issues you get with true bitmap indexes. These, by the way, are cost-based transformations, but all too often the optimizer doesn't make them when it should, and they have to be hinted. However, do you really want hints in your production code? Probably not. So, let's try the alternative. Tuning the SQL. First, using a set operator. The set operators are, I believe, underused by many developers. In this case, I would say that an intersect looks like a nice, intuitive solution. Select ename from emp where depth_no equals 10, intersect. Select ename from emp where job equals clock. So what we'll be doing here is getting all the people in that department, then a second row set, all the people with that job, and return the common rows. So the intersection has two branches, and both of the branches are indexable. Looks good, but it isn't. On this occasion, the use of intersect is actually a bug, because you have to think about duplicates. The set operators, with the exception of union all, will remove duplicates. So if there happen to be two people with the same name in the same department with the same job, you'd be losing one of them. So when you use set operators like this, you do need to make sure that you include typically a primary key. So the debugged version is this, where I include emp_no as well, and that will ensure that we do get every row that we should. It's frighteningly easy to forget that sort of thing when using set operators. A second option is an exists subquery, like this. Select ename from emp_e where depth_no equals 10 and exists. Select 1 from emp_f where f.emp_no equals e.emp_no and f.job equals clock. This is a correlated subquery. Correlations can be good, but depending on the data, they may result in excessively repeated executions of the subquery. In principle, this subquery is, I'm asking Oracle to run this subquery once for every row returned by the calling query. There are various optimizations that mean it will rarely be that bad. But even so, correlations can result in excessive the repeated executions. What happens when I run this? Very nice. A nice optimization. Oracle has realized that perhaps the correlation is a bit inefficient, so it's rewritten the query to a join. And both branches of the join are indexable. A nice optimization. But when you see something like this, it should make you think. You wrote a correlated subquery, and Oracle rewrote it to a join. Perhaps it should have been written as a join in the first place. Like this, for example. Select d.ename from, select ename empno from emp, where department number equals 10, join, select ename empno from emp, where job equals clock, and the join column empno. And now we get an interesting variation. When the optimizer rewrote my correlated subquery to a join, it rewrote it to a nested loop join. Here I've explicitly coded it as a join, and it's been implemented as a hash join. An interesting variation there. But what matters, either way, is both branches of the join are properly indexable. To conclude, whenever you see a conjunctive query, one that uses AND, be aware that index usage may be severely limited. Also, by the way, unless you have appropriate column group statistics, the cardinality estimates may be well off too. The optimizer will do its best to rewrite conjunctive queries to enable index access paths, but often it can't manage to do it as well as you might like. So, perhaps give the optimizer a hand. Rewrite the SQL yourself.
If you liked this video, please like it and subscribe to our channel.